This video is on the trends in the chemical properties of group 2 elements. And our aims for this video are to know the reactions of the group 2 elements with water and recognise the trend, know the trend in solubility of the group 2 hydroxides, know the trend in solubility of the group 2 sulfates, know the use of magnesium hydroxide and calcium hydroxide, and know the use of barium sulfate in medicine. There's a very distinct trend in the reactivities of the alkaline earth metals group 2 elements with water. I'm going to try and show you those via video. So this first one I'm going to show you is the reaction of magnesium with just water. In this, that there were, if I just go back a second, now if we compare that with calcium in water instead, so this next video, so calcium is just one down in the periodic table underneath magnesium in group 2, there's magnesium, there's calcium. So let's just see how that affects the reactivity of the calcium with water. Formed in. So you can see it's very cloudy, lots of hydrogen being formed, and you can see the reactivity of the alkali metals with water is getting greater down the group. The reaction that's happening here is exactly the same. We've got calcium plus plus water, two of them, and that goes to make calcium hydroxide. The same general formula, 2 hydroxide ions are needed to counteract that 2+ charge on the calcium, and you'll also make hydrogen. This is far more reactive, the calcium, and so the reactivity of the alkaline earth metals gets greater as you go down the group. The last reaction I'm going to show you is the reaction of magnesium with steam. So that is basically heated water, and you would expect the reaction to be much more vigorous, and you can see that it is. But the other property you have to take away from this reaction is that but magnesium oxide. So this time, if you use steam, so magnesium with H2O, but in this case, instead of being a liquid, it is a gas, you'll make instead magnesium oxide, which is MgO, plus hydrogen still, which you can see quite clearly from the flame that's produced. So, take away from this, first, magnesium forms different products with the water in different states, if you like. With liquid water, it'll form magnesium hydroxide and hydrogen, but with gaseous water or steam, you'll form magnesium oxide and hydrogen. And the other thing to take away from this slide is that the group 2 elements get more reactive with water as you go down the group. The reason for that is the same reasons why alkali metals get more reactive with the group 1 metals. It's because the electrons that are being transferred, if you like, during the reactions are getting further away from the nucleus and so therefore are easier to remove. Now in the specification it doesn't state that you need to know that, but it's something that you could, I suppose, get asked, just because it maybe is general knowledge from GCSE. So the general formula for a group 2 hydroxide is X, where X is the group 2 metal, open bracket OH2. The reason for that is that group 2 metals form 2+ ions, and the hydroxide ion is a 1- ion. And so you need 2 hydroxide ions to counteract the 2+ charge on the metal ion. So this means that beryllium hydroxide would be BeOH2, magnesium hydroxide would be MgOH2, calcium hydroxide the same, and so on. But what you need to know is the solubility of the hydroxides, and as you go down the group, they get more soluble in water. The reason for that, you don't need to know, but you do need to know that they get more soluble in water down the group, and that's the hydroxides. The sulfates, however, are the opposite. We'll just discuss what the formula is for those. So group 2 sulfates have the formula XSO4. That's because the sulfate ion, SO4, has a 2- charge, and the group 2 metals would form ions with a 2+ charge. And so you only need one of the sulfate ions to counteract 2+ charge on the metal ion. So this time we will have BeSO4 for beryllium sulfate, MgSO4 for magnesium sulfate, CaSO4, and so on. And this time, down the group, they are less soluble. This means that barium sulfate doesn't dissolve at all in water, which gives it uses in medicine, which we'll discuss a bit later, even though barium is very toxic. So let's just discuss some uses for the hydroxide. So magnesium hydroxide and calcium hydroxide have different uses. Magnesium hydroxide is often used in indigestion remedies. And the reason for that, it is used in antacids, and the reason for that is that it neutralises the stomach acid that is built up and causes the indigestion. Calcium hydroxide is also an alkali, and that can be used to alter the pH of the soil in fields so that different crops can be grown. So it's spread on fields, CaOH2, spread on fields to alter the pH of soil, or even to neutralise the soil if acid rain has taken hold. Finally, barium sulfate is one of the compounds you specifically have to know a bit more about. And barium sulfate is used in medicine as a barium meal. The reason why barium is taken orally is so that X-rays can be taken of the organs, specifically the digestive system. The reason for that is that internal organs generally don't show up on X-rays because they are soft tissue, it's bones that show up on X-rays. So to make the organs show up on X-rays, you have to ingest something that will then kind of coat the organs that will also reflect the X-rays. And barium will do that. So you can see here that this is the X-ray of someone who's taken a barium meal, and you can see what I think is the large intestine has shown up on the X-ray. And so what we call these is a barium meal, and we take it to, so it enables X-rays of digestive system to be taken. And barium is actually very toxic. So if you took barium and it dissolved in your bloodstream, it would poison you. But the reason why a barium meal is safe is because barium sulfate is so insoluble that it won't dissolve in the bloodstream. So even though barium is toxic, BaSO4 is not, as it is insoluble in water. And so therefore does not get into your bloodstream.